Okay, so good evening. Our topic for today, of course, is about extraction, transformation, and loading. So again, when we say extraction, no, most commonly, no, in the extraction, transformation, and loading, that is ETL, no, in data warehouse, no. So you need to load your data warehouse regularly so that it can serve its purpose of facilitating business analysis. No? So to do this, the data from one or more operational system needs to be extracted and copied into the data warehouse. So the challenge in data warehouse environment is to integrate, rearrange, and consolidate large volumes of data over many systems, thereby providing a new unified information base for business intelligence. So the process of extracting data from source system and bringing it into the data warehouse is commonly called ETL, no? Extraction, transformation, and loading. So which stands, of course, as I mentioned, for extraction, transformation, and loading. So note that ETL refers to a broad process and not three well-defined steps. So the acronym ETL is perhaps too simplistic because it omits the transportation phase and implies that each of the other phase of the process is distinct. Nevertheless, the entire process is known as ETL. So the methodology and task of ETL have been well known for many years, no, and are not necessarily unique to data warehouse environments. So a wide variety of proprietary applications, no, and database systems are the IT backbone of any enterprise. And data has to be shared between application or system, trying to integrate them, giving at least two applications the same picture of the world, no? And this data sharing was mostly addressed by mechanisms similar to what we know called ETL. Okay, so to continue, no, what happened during the ETL process? So the following tasks are the main actions in the process. Number one, extraction of data. So during extraction, the desired data is identified and extracted from many different sources, including database system and applications. So very often, it is not possible to identify the specific subset of interest. Therefore, more data than necessary has to be extracted. So the identification of the relevant data will be done at a later point in the time, no? Depending on the source system capabilities. No, let's say, for example, operating system resources. Now, and some transformations may take place during this extraction process. The size of the extracted data varies from hundreds of kilobytes up to gigabytes. Now, depending on the source system and the business situation. So the same is true for the time delta between two logically identical extraction. So number one, the time span may vary between days, hours, and minutes to near real time. Web server log files, for let's say, for example, can easily grow to hundreds of megabytes in a very short period of time. Another, of course, is the transportation of data. So after data is extracted, it has to be physically transported to the target system or to an intermediate system for further processing. So depending on the chosen way of transportation, some transformation can be done during this process. Let's say, for example, a SQL statement which directly accesses a remote target through a gateway can concatenate two columns as part of the select statement. So the emphasis in many of the example in this selection is scalability. So many long-time users of Oracle database are expert now in programming complex data transformation logic using, of course, PL/SQL. No? And this, of course, alternative such that data manipulation operations with a particular emphasis on implementation that take advantage Oracle's new SQL functionality especially for the ETL and the parallel query infrastructure. Now, ETL tools for data warehouses. Now, designing and maintaining the ETL process is often considered one of the most difficult and resource-intensive portions of the data warehouse project because many data warehousing projects use ETL tools to manage this process. No? Oracle Warehouse Builder, no, yung OWB natin, let's say for example, provides ETL capabilities and takes advantage of inherent database abilities. No? Other data warehouse builders create their own ETL tools and processes either inside or outside the database. So besides the support extraction, transportation, and loading, there are some other tasks that are important for a successful ETL implementation as part of the daily operations of the data warehouse and its support for further enhancement. So besides the support for designing a data warehouse and the data flow, these tasks are typically addressed by ETL tools such as OWB or what we call Oracle Warehouse Builder. So in daily operations in data warehouse, no, the successive tools or even the successive loads and transformation must be scheduled in process in a specific order, depending on the successes or failure of the operation or parts of it. So the result must be tracked and subsequent alternatively processes might be started. So the control of the progress as well as the definition of business workflow of the operations are typically addressed by ETL tools such as Oracle Warehouse Builder. So it means to say that one of the best example of ETL is the OWB or Oracle Warehouse Builder. So actually, as the data warehouse is a living IT system, source and targets might change, and those changes must be maintained and tracked through the lifespan of the system without overwriting or deleting the old ETL process, flow of information. So to build and keep a level of trust about the information in the warehouse, the process flow, each individual record in the warehouse can be reconstructed at any point in any time during reconstructed at any point in the future in an ideal case. So I just want to share with you a video presentations, as an additional input for the ETL, specifically for extract, transform, and load.
My name is Vikram Thakur. Welcome to this video on ETL. In the previous videos, I have given an overview about data warehousing and its architecture. In this video, we're going to talk about one of the most important aspects of data warehousing, which is ETL. So let's get started. ETL stands for extract, transform, and load. As we mentioned in the previous videos, that data is read from the heterogeneous sources, from the source systems, and loaded into staging table. And then finally, after the transformations are complete, it is loaded into a data warehouse. So the complete process of extracting the data, transforming the data, and loading the data into warehouse is called extract, transform, and load. It is not a one-off process for a data warehousing, because data in the operational systems and the source systems keeps on changing. So this is a regular process where the data has been regularly fetched from the source system and loaded into a warehouse after transformations are complete. So this is important aspect of the warehousing, because if the source data from the operational systems and the source system is not extracted, cleansed and integrated into a proper format in the warehouse, then it will be difficult to perform the query processing efficiently, which is the ultimate purpose of the data warehousing. So ETL has three phases. First is the extraction part, second is the transformation, and third is the loading of the extracted and the transformed data into the warehouse. So let's look into each of these three stages in detail. So first is the data extraction. So as we earlier mentioned, the data from the various sources has been extracted into the staging area as a first step in the data warehousing. So there are a couple of data extraction strategy. First is the full extraction, wherein all the data from the operational systems and all the source systems gets extracted into the staging area. So this generally happens in two scenarios. One, for the initial load when the data warehouse is getting populated first time, or in the scenarios where we do not have any strategy for identifying the changed record. So we extract the full data and do all the transformation and identify all the changed or the modified records on the staging area. So in this strategy, we extract all the data from the source systems into our staging server. Next is partial extraction with update notification. So sometimes we get the notification from the source systems that which data has been updated, which data has been deleted, and which data is the new data. So this is also called the delta, and in this strategy we only extract the data which has been modified, and it is easy and quick as compared to the full extraction. And the next strategy is the partial extraction without update indication. So in this strategy we do not extract the full data set from the source system. We extract the data based on certain keys or certain strategies. For example, we have populated data, or we have already extracted data till yesterday. So we extract today's data and then we identify all the updates on that data. One thing we need to remember while extracting the data from source system is that it should be designed in a way that it does not negatively affect the source system performance, because source system is generally where all the actual business and the transaction happens. So we should design our system or schedule our system to run at that time that it should not negatively affect the source system performance. So let's move on to the next phase, which is the transformation phase. So the data extracted into the staging server from the source system is in a raw format, and we cannot use the data as it is. It has to be cleansed, mapped as per the requirement, and transformed before it is finally ready for loading into a data warehouse. So this stage, all the transformations, all the cleansing and all the mappings happen. So let's look at the basic transformation tasks. First is the selection, wherein we select the data which is required to be loaded into a data warehouse or which is actually meant to be transformed. So in this step we select those data. Next step is the matching. In this step we look up the data from various lookup files and then match the data that needs to be transformed. Next part is data cleansing and enrichment. So data is not cleansed in our source systems. It is not standardized because we are fetching the data from more than one source system. So it has to be standardized or normalized. Hence we do the data cleansing and enrichment. And the last is consolidation and summarization. As we mentioned earlier, we consolidate and aggregate the data from the source system because we do not want to load same data from the source system into a warehouse. Hence we consolidate, summarize and aggregate the data from source system in the transformation phase. So let's look at some of the sample transformations that we apply on a data. First is standardizing data. As I mentioned earlier, data has been fetched from various sources and then it needs to be standardized before loading into a warehouse. Character set conversion and encoding handling. We also need to convert the data into a defined encoding in the data warehouse because the source system may or may not have the same encoding. We calculate and derive new columns from the existing columns. We split and merge fields, split it from a single field to multiple fields, and then we combine some fields as well, and this all happens based on the requirements. We convert units because source system may have a different way of storing a particular measurement, but we convert into a standard format. For example, we convert the date time, we convert the units of measurements into a standard format. Summarization, aggregation of data and consolidation. Deduplication is also done as a part of transformation, in which we delete the duplicate data that we receive from multiple sources, and then finally we do the key restructuring. Key restructuring is important because we do not use the same keys that we use in our operational system in our data warehouse. In data warehouse has a concept of surrogate keys. Surrogate key are the non-meaningful keys, and it should be generated irrespective of the keys or the primary keys defined in the source systems. So we design our data warehouse so that we populate the surrogate keys using the data from the source systems. So next is loading the data into the warehouse from the staging server. We fetches the prepared data in the transformation phase and load it into a data warehouse. Now there are types of loading strategies we use. First is the initial load. As I mentioned, when we load the data for the very first time, we do not care about identifying the newly or the modified records. We generally take the whole data set from the staging server and load it into a data warehouse. So this is a one-off process, and it is generally done when the data is going to be populated for the very first time in the data warehouse. Next is the incremental load. So this is when we apply all the ongoing changes from the source system into the data warehouse periodically. So in this we only load the records which has either changed or the newly inserted records into source systems. And the last is full refresh. We sometimes require to do a full refresh as well, which is basically completely erasing the contents of one or more tables and loading the fresh data. For certain tables we do not want to keep the history of changes, so it is better if we completely erase those tables and load all the data which is extracted from the source systems. So this completes about the loading strategies. So next is the ETL tools. We have a couple of ETL tools. There are enterprise softwares which are Informatica, IBM DataStage, Microsoft Integration Services, Ab Initio, and Talend and Clover ETL. These are full-fledged enterprise softwares. We have a couple of open source and community softwares as well, which is Pentaho, Kettle, and Talend. Clover also has a open source version, but it is very limited to certain transformations only. Now let's look at what are the features and capabilities of ETL tools. The data connectivity with the source and the target system. The ETL tool should allow to connect to the source system and the target data systems efficiently and seamlessly. Next is scalability and performance. We should not be able to change a job in order to perform it better whenever our data has been increased, whenever our business do some acquisition. So we should scale the ETL jobs by adding more clusters. ETL tool should have a lot of pre-built transformation connectors which allows us to do the transformation easily and quickly. ETL tool should also have a data profiling and data cleaning components which allows to standardize and clean the data, because the data from the source system may or may not be clean or may not be in the same format. So data profiling and data cleansing allow us to make the data standardized and improve the data quality. ETL tools should also have capabilities to easily perform logging and exception handling. It should have robust administration features which allow us to schedule the jobs, which allow us to assign the jobs to particular users, and which allows multiple developers to work simultaneously.
Okay, so again, the ETL, no, or extraction is the operation of extracting data from a source system that further used in data warehouse environment. And this is the first step of the ETL process. So after the extraction, this data can be transformed and loaded into the data warehouse. No, so actually we have online extraction, we have the offline extraction. No, and when it comes to change data capture, no, we have timestamp, partition, and triggers. No, and most commonly we use select, the asterisk from orders, no, where, trunk, no, cast, no, order underscore date as date, then yung the date, the to underscore date, then sys date, then the format of the year, no, the day, month, and year at the same time. So this will be the also what we call timestamp informations, no. And a data warehousing extraction example, of course, is the extraction using data files and extraction through distributed operations. So when the source system is an Oracle database, several alternatives are available for extracting data into files. No, extracting into flat files using SQL asterisk plus, extracting into flat files using OCI or Pro asterisk C programs. No, we have also exporting into export files using the export utility, and extracting into export files using external table. Actually, no, this discussion actually is too long, no, but we need to understand that transportation, on the other hand, is the operation of moving data from one system to another system. So in a data warehouse environment, the most common requirements for transportation are in moving data from number one, a source system to a staging database rather, or a data warehouse database. No, staging database to a data warehouse, and a data warehouse to a data mart. No, transportation is often one of the simpler portion of the ETL process, and it can be integrated with other portions of the process. Let's say, for example, no, extraction in data warehouse. No, distributed query technology provides a mechanism for both extracting and transporting data. So transportation mechanism in data warehouse, we have three basic choices for transporting data in warehouse. Number one, transportation using flat files, transportation through distributed operation, and transportation using transportable table spaces. No, and most commonly we use this one, let's say for creating table, no, or using alter table space in our database actually, no. Okay. Another, of course, is the loading, no, loading in transformation. So data transformation are often the most complex, and in terms of processing time, the most costly part of the extraction, transportation, and loading process. So they can range from simple data conversion to extremely complex data scrubbing techniques. No, many, if not all, data transportation can occur within an Oracle database, although transportation are often implemented outside of the database. Let's say, for example, on flat files as well. No, So transformation flow, of course, from an architectural perspective, you can transform your data in two ways. Number one, multi-stage data transportation and transformation rather, and pipeline data transformation. So we have also the loading mechanism, no? And following mechanisms for loading a data warehouse. Number one, loading a data warehouse with SQL asterisk loader, no? Loading a data warehouses with external tables, loading a data warehouse with OCI and direct path APIs, and loading data warehouse with export or import. No, we have also loading data warehouse with external table, as I mentioned earlier. No, and most commonly, of course, we could able to use also the merge operation using SQL, no, and we could able to use transforming data using multi-table insert, no, and unconditional insert at the same time, and conditional all insert. Conditional first insert that is also covered in our SQL is specifically used in our Oracle, no, database. So transforming data using table functions. So the table functions provide the support for pipeline and parallel execution of transformation, no, implemented in PL or SQL, C or Java scenarios as mentioned a while ago, done without requiring the use of intermediate staging tables, which interrupt the data flow through various implementation or various transformation steps. No, so the table functions, of course, is defined as functions that can produce a set of rows and as output. No, a table function can take a set of rows as input prior to Oracle 9, no, PL SQL functions. No, it could not take cursors as input. It could not be parallelized or pipeline, no, and so on. So, and there's certain, of course, way on how we'll be able to use degree of parallelism to the input table, products, and issue the same statement again, actually, no, especially with this part. No, error logging and handling mechanism for business rule violation, data rule violations, no, must covered also with this transformation. And for the loading and transformation scenarios, we have the K-lookup scenario, business rule violation scenario, data error scenarios, business rule violation scenario, and pivoting scenarios. No, so that is also part of the transformation actually. And using partition to improve data warehouse refresh, no. Actually, ETL also done on a schedule basis to reflect changes made to the original source system. So during the step, you physically insert the new clean data into the production data warehouse schema, and take all of the other steps necessary, such as building indexes, validating constraint, taking backups, no, to make this new data available to the end user. So once all of this data has been loaded into the data warehouse, the materialized views have to be updated to reflect the latest data, no? So yun ang ginagawa niya automatically. Then another thing, of course, is the change data capture, no, and open, no, data warehouse or data warehousing involves the extraction and transportation of relational data from one or more production databases into a database warehouse for analysis. So change data capture quickly identifies and processes only the data that has changed and makes the change data available for further use, no. Sorry. We have also what we called actually a data warehouse performance, no, and it covered, of course, basic query rewrite, advanced query rewrite, no, and so on and so forth, no. And this is one subject actually, no, covered for this discussion. So again, Oracle database releases for source and staging databases. So Oracle Database Release 9.2, 10.1, 10.2, 9.2, or 10.1. Oh, of course, is the Azure database of distributed hot log mode, no? And use upgrading the distributed hot log change source to Oracle Release 2.10, no? So when it comes to hardware platforms and operating system, the distributed hot log mode actually of change data capture support the use of different hardware platforms or operating systems for both for the source and staging databases. No? So I think that's it for this topic.